So today we're talking about sum and difference identities. These again are identities that you do not need to know. They will be given to you on any quizzes or any test that we take. Okay? You guys are going to be able to use these identities to simplify and solve trig expressions or equations. So here are the identities listed. These are just the ones that I typed up, the ones that I already printed out for you. Instead of having U's and B's, they have alphas and betas. Basically, all U and B, alpha and beta, they just represent an angle. Okay, so you can use any variable with them. You can use X and Y, A and B. Okay, they just represent variables. But it's pretty straightforward. Anytime you see sine of an angle plus another angle, this is the formula that you use. It's pretty simple. You just plug in sine of angle U, cosine angle B, plus cosine angle U, sine angle B, and so on and so forth. I mean, it's pretty straightforward. You'll have that in the It's more like plug-in type thing. Yes, sir.
So these are the same ones.
Yes, the only difference between yours and the ones that are up here is that instead of using these, it's alpha and beta.
Wait, were we provided with these?
Yes. All right. So we're gonna, and that's pretty much it. It's just using the identities to verify, simplify, solve equations. Okay. So here's our first two examples. Okay, out of the 10 or 11 that we do. Give you guys a second. All right, we are verifying this identity now. Now, number one should look very familiar. What is number one?
It's one of those functions.
Which identity is this? It's a co-function identity. One of the ones you have to remember. We're basically going to verify why this is true. You guys remember how to verify identities?
Left equal right.
The left has to equal to the right, and we always start with the what?
More complicated side.
More complicated side, which is clearly the left side. Okay? Now, if you look at just the left side, it says cosine parentheses pi over 2 minus x. Look at your sum and difference identities. Look at that little slip of paper I gave you. Isn't there an identity that says cosine alpha minus beta?
Yes.
You would use that full formula to basically expand this out. Okay? So, this is going to be the alpha, this is going to be the beta that's in your formula. So it starts out by saying cosine alpha, cosine beta, does it not?
Yes.
So instead of putting an alpha, I'm going to put a pi over 2, then cosine of beta. I'm going to put a x. Then the rest of the formula says plus, correct? Plus?
Yes.
Sine of alpha. So I'm going to put a pi over 2. Sine of beta. So I'm going to put an x. It's
Negative x or just positive?
it's always the positive. This basically lets us know that it's going to be a plus in the middle.
Wait, so
Caleb asked, would it be a negative x? And I said, no, this sign basically lets us know which identity we need to use. So the fact that it's a minus means we're using the difference formula here, which gives us a positive in the formula.
that's what I was thinking too.
True, but we're verifying. We are showing why it does equal sign.
Right.
That this is it. We're showing why this is the case.
Will
Will they always be this simple? No. I'm just showing you why it was signed. Okay, I know you all trusted me when I gave them to you. Now I'm showing you why this was the way it was.
Sure, it's all word line.
Exactly. What's the cosine of pi over 2? What's the cosine of pi over 2? 0. So this is 0 times the cosine of x. What's the sine of pi over 2? 1 times sine over x. So it does indeed equal sine x. We have just verified this identity because 0 times cosine x cancels out. That's why it equals sine. Okay? I know you all just trusted me when I gave you the co-function identities and you just ran with it. But this is why. Okay?
Is this another identity?
The one in the black is the identity we just verified. We just showed why it equals sine x.
Oh, okay. So this is that.
That's how you use your sum and difference identities to verify something.
Question.
Yes.
How many problems do you want to stage?
You should at least try to get 4. If you can get more than this.
What if we changed cosine to sine? Would we be considered wrong?
What do you mean change cosine to
We
sine?
didn't do all the extra steps.
If you try to change this, you mean?
Yeah, just to sine the whole thing because that does equal sine x.
Okay. So still a subtraction, so we're going to use the same type of formula. It's still going to be cosine alpha, cosine beta, plus sine alpha, sine beta. Okay? And you plug everything in. So cosine of what? Theta, cosine, just 3 pi over 2. Not the negative. So it's going to be a positive 3 pi over 2. Then this is going to be a plus or minus?
Plus.
Plus sine theta. Sine 3 pi over 2. We're trying to show that this doesn't equal negative sine theta. So here, we just simplify. We have cosine theta times, what's the cosine of 3 pi over 2? 0. Plus sine theta, what is the sine of 3 pi over 2? This cancel out, negative sine theta. So when I was trying to show you guys that before with cofunction identities, that's why. Makes sense. Yes, ma'am? Because it's cosine theta times cosine of 3 pi over 2. So this cosine of 3 pi over 2 is 0. 0 times anything is 0. Let's look at another one, another example, unless there are questions. On what part? Alright, here's the next one. Alright, look at number 3. We're still verifying, same directions. What side are we going to work with? The left, the more complex. Now this is a tangent, alpha plus beta. Do you guys see which identity we're going to use? The top one for the tangent. Now the formula goes tangent alpha plus tangent beta. So that's going to be a tangent theta plus tangent 3 pi. Is everybody with me? All over 1 minus tangent alpha, which is tangent beta, which is 3 pi. And you cannot cancel these out because technically we are subtracting those and we're adding at the top. Okay, so we can't cancel out the tangent 3 pi, we can't cancel out the tangent theta. Okay, so we are going to have to simplify this. Now, 3 pi, I know it's not on your unit circle, but 3 pi is also the same thing as saying, so it's pi. What's the ordered pair at pi? Negative 1, 0. Tangent is what over what? What is 0 over negative 1? So the tangent of 3 pi is, so this is tangent theta plus 0 all over 1 minus tangent theta times 0.
So basically,
It's going to be tangent theta all over 1, which is tangent theta.
here's my question.
Your question.
In this situation that we're doing in verifying, is there always a reason?
No.
What happened with the negative
You need the minus tangent theta? Well, I still had it right here. I had 1 minus tangent theta. I just turned tangent 3 pi into 0 because that's what it is. So then 0 times tangent theta cancels out. And so I'm left with 1 minus 0, which is just 1. Okay? Are you guys okay? So I want you guys to try 4. It's two of them. Okay? Alright, so this is the problem. Cosine pi minus theta plus sine pi over 2 plus theta, it has to equal 0. Clearly your more complicated side is your left hand side. And I just did this just to help those out who still might be struggling, is that this is how they match up. Okay, you're using this difference identity for cosine. Alpha is now going to be pi, and beta is now going to be theta. So when you go to plug it into the identity that matches up with the difference identity, it becomes cosine pi cosine theta plus sine pi sine theta. Did everyone get that?
Yes.
So then, what's the cosine of pi? Negative 1. So that's negative 1 times cosine plus what's sine theta? 0 times sine theta. Does anyone see that? That simplifies down to be what? Negative cosine theta. Now you do the same thing with the sine of pi over 2 plus theta. It's just now alpha is going to be pi over 2, theta is now going to be theta, and you plug in pi over 2, theta, pi over 2, and theta. Did you guys get that?
Yes, ma'am.
What's the sine of pi over 2? 1. What's the cosine of pi over 2?
0.
What does this simplify down to be? Cosine theta. So the first part is a negative cosine theta. The second part is a positive cosine theta, and that equals 0, which is what it should be. Does anyone see how it matches up with the identities? With the respective identities? Okay.
Read the
Sometimes they're gonna come kind of nastily. Nasty. So I'm gonna jump it down a word. So kind of nasty. But remember, it's either gonna be a 1 to 0, a 1/2, a root 3 over 2, a root 2 over 2 when you're dealing with sines and cosines. Okay? So if anything, if it does end up being two fractions, they'll have the same denominator, and so then you can add the numerators. So it won't be nothing too crazy. Tangent, that's when you get a little sticky. Okay? This one, 5. Last one on the verifying. Okay? You guys gonna give it a go?
Yeah.
All right. It's the same thing, except instead of using pi's and thetas and alphas and betas, I use what? A and B. They're just variables. So this, in the formula, this is going to be the alpha. This is going to be the beta. Okay? Give it a try. No, don't split first. You guys get that? So now here we're trying to make it equal tangent A plus tangent B. These can be split up into two separate fractions. You have sine A, cosine B, all over cosine A, cosine B.
How are you going to do that?
Because we're trying to make it equal tangent A plus tangent B.
Okay, that makes sense.
See, I got 2 minus.
Oh, is this a plus here in the identity? That's probably why. What do you notice?
Certain things they cancel out.
What cancels out in this first fraction?
Cosine B.
And I can't cancel this way because everything in this first fraction is being multiplied together. So these cancel. What about the second fraction?
Cosine A.
Cosine A cancels because again they're being multiplied. So you're left with sine A over cosine A and sine B over cosine B. What's sine over cosine? So we have tangent A plus tangent B. And that's what we're trying to think about. So all this is using the identities that I'm giving you. So again, you don't have to memorize these, you just gotta know how to use them, okay? Let's solve some now using these. And we're gonna do them on the interval from 0 to 2 pi. Because I think, like I said, you got the idea around the whole all part. Alright, so look at this one. We are solving. And unlike the other problems that we solved, there are no squares here. And it's definitely not just sine of an angle. It's sine of like x plus pi. It's more than just one thing, correct?
Yes.
So you should be able to look at this and say, oh my goodness, these are sum and difference identities.
For the x minus pi before, when you're plugging in that, you do negative pi before?
No, it's always possible. the identities again. We're going to have two here. The one that's signed in the plus, and then the one that's signed in the minus. So this is alpha, this is beta, and this is alpha and beta. We'll use the formulas, okay? So we're going to use the formula. It says sine alpha, cosine beta, plus cosine alpha sine beta. And granted, I am saying alpha and beta, but I'm writing in what alpha is and what beta is. That's the first part. Is everyone okay? Now I'm going to use the other identity. This is a plus. Now, if this was a minus, you would need to subtract the entire second identity. Just keep that in mind, use parentheses. Sine alpha cosine beta minus cosine alpha sine beta, all that equals 1. Negative.
So if you subtract, can you just flip the signs?
Huh?
Can you flip the signs and then do
I'm sorry, I can't hear over you. Say it.
could you do like flip the signs? If it was like subtracting?
Yes. So say this was a negative instead, you would need to subtract this entire second part. So you would need to change the signs, and that is crucial. Okay? Yes, ma'am.
Could you subtract the cosine and sine power from the positive one?
You surely can. Yes. You can recognize that these here cancel out. They certainly do. Okay? So, because we are solving, which means we do have, if we can simplify in different places, we want to do that. So those cancel. And yes, there are two of these. So this would be technically 2 sine x cosine pi over 4. What is cosine of pi over 4? Don't freak out. Yes, it's something other than 1 and 0. But what do you notice about if you multiply 2 and then square root of 2 over 2?
Just one.
It just becomes root 2. Sine x equals negative 1. How? Well, because they're being multiplied. This is technically 2 over 1 times root 2 over 2. The 2's end up canceling out. And now how do we solve this?
You would root the 2, right? And then square or rationalize.
Yes. So how do I move the root 2 over?
Divide by root 2.
Divide by root 2. And yes, we do need to rationalize.
Find x equals negative root 2 over 2.
Is that a value on our unit circle? Yes. Where is sine a negative root 2 over 2? Third quadrant, yes.
Oh,
And there's one more. And those are your solutions.
interesting.
Yes. This part? Well, because we're multiplying the 3 of these things, we can technically do 2 times root 2 over 2. Hold on, stop talking, y'all, please. So then, this is the same thing as just saying 2 over 1. The 2's cancel out, and then you're just left with root 2 over 1, which is just root 2. Yes?
For these, you don't add the 2 and highlight, it's not all.
Correct, because I'm giving you the
Oh, okay.
restriction. Alright? Try this one. I want you to try this one. guys get this? Now, I mentioned it before, but you have to be careful because there's a minus here. You have to make sure that you're subtracting the whole second expansion, which means that when you need to carry this negative over. So this will end up being a minus cosine x, cosine power 6, and this ends up becoming a minus as well. So then, technically, these two terms are going to cancel out, but these can be combined. So you have a negative 2 sine x sine pi over 6 equals a positive 1. Now, will terms always cancel out? No. No, they won't. But you just simplify, combine like terms, and just go from there. Okay? What is the sine of pi over 6? What's negative 2 times the 1/2? A negative 1. So this is just negative sine x equals 1. So sine x equals a negative 1. And x is going to be what value? 3 pi over 2. That's how these solving problems go. Alright? So you basically use your identity. Sometimes you can cancel things out like we've done on this problem. Sometimes you are going to have to actually do, like work them out. So then you'll have like, negative sine x or like root 3 over 2 sine x. Then you just combine like terms. Yes, sir?
So sine x equals -1.
Because you're looking at where on your unit circle is the y value at negative 1. And that's 3 pi. Okay? We're going to look at one more together. A little different. We are still solving on the interval. And then the bell's going to ring a little bit, so this will be the last one we do. Yes, you will have homework, but it won't be the whole thing. So you can get 2 examples. Okay? So, let's use our formula. Is everyone okay up to here? Double checking with my identity. Yes, alpha plus beta is a plus on the top and a minus on the bottom. For this one, it is going to be 2 times the whole identity. Okay, anytime there's a coefficient in front, it's that whole identity and then the coefficients on the outside. So if anything, just treat them separately. First part, second part. Now, unlike the other one, I can't really cancel things out because I got tangents and I got sines and cosines. So I just gotta evaluate. What's the tangent of pi?
0.
It is 0. So this just turns into a tangent x all over 1 minus?
Oh no. 0.
0. So it's just going to be 1. So just have a tangent x, right?
Yep.
Over here, I'll have a sine x times, what's cosine of pi? Negative 1. So this turns into a negative sine x. What's the sine of pi? 0. So this will just be nothing. Is everyone okay? This full, long, complex expansion really simplified down to something a little bit smaller of just tan x, technically minus.
This is all the stuff on the right side.
Yep, this is everything that's on the left side.
Oh, left side.
And all that equals 0. Now I am solving this. What do you think might be a good thing to do to solve this?
Switch everything to sine this.
So if I change tangent x to what?
Sine is good.
This This is one that's a little bit more involved. That's why I wanted to do this one with you. Multiply this by cosine? I do need a common denominator.
This is the last unit, right? Or is this the beginning of this unit?
This is the middle of the same unit.
No, I mean like when you're doing that. When you're doing question like the bonds where you like getting common denominator.
That's like the beginning.
Teachers, at this time we do have one. And again, I would like to congratulate our.
So from here, because we have a common denominator, we can write it as one fraction. And that equals 0. Now to solve this, we need to get rid of the denominator. So if we multiply both sides by the cosine of x, well 0 times the cosine of x is basically going to go away, and we're just left with cosine x minus 2 sine x cosine x. From here, we can use our rules of factoring. We can factor out the GCF of a sine x. That leaves us with 1 minus 2 cosine x. Then we can set both factors equal to 0. That sine x equals 0. And then here, that's going to be a 1/2 equals a cosine of x. Since we're on the restriction of from 0 to 2 pi, we're looking for where sine equals 0 on our unit circle. That happens at 0 and at pi. And then where cosine is a positive 1/2, that's at pi over 3 and 5 pi over 3. So then those would be our answers. And that's the bulk of solving with these sum and difference identities. Okay? Now I am going to continue the video. And you guys are to watch this, add to your notes. There's going to be 4 examples, 2 of finding the exact value and then 2 of simplifying. So if you notice, the exact value, whenever it says exact, that is not a decimal approximation. That is a fraction, that is a whole number, that could be a radical. But basically, you can't use your calculator to do this. But if you look, negative 15 degrees nor 7 pi over 12 is on your unit circle. So what do? What you actually have to do is you have to figure out what 2 values on your unit circle either add to give you a negative 15 degrees or subtract to give you a negative 15 degrees. Because once you figure out what those 2 angles are, then you'll use the sum and difference identities to find their exact value. So think about it. What degree measures, I need 2 of them, will either add to give me a negative 15 degrees or subtract to give me a negative 15 degrees. And they have to be on your unit circle. Well, the 2 that I came up with are 30 and 45. If I do 30 minus 45 degrees, doesn't that give me a negative 15 degrees? That it does. So basically, I rewrite it as 30 degrees minus 45 degrees, and then I can use my cosine difference identity, which says cosine alpha, cosine beta, plus sine alpha, sine beta. Okay? So again, to find exact values of values that are not on your unit circle, you can use your sum and difference identities to find the exact values. Then all you have to do is, knowing your unit circle, what's the cosine of 30 degrees? That's root 3 over 2. What's the cosine of 45 degrees? That's root 2 over 2. And what am I doing to these 2 values? I'm multiplying them. What's the sine of 30 degrees? That's 1/2. The sine of 45 degrees is a root 2 over 2, and I'm multiplying those as well. So then that turns into a square root of 6 over 4 plus a root 2 over 4. And because they have the same denominator, I can write it as 1 fraction. Now, if you're like, okay, wait, hold on, where did the square root of 6 come from? Well, when you're multiplying radicals, you just multiply the numbers underneath the radical. So that's a 3 times 2, which gives you 6. And then, of course, we multiply the denominators. And that is the exact value. I can't go any more simple than that. That's going to be my final answer. So So again, the trick is to figure out what two angles are either going to add to give you that number or subtract to give you that number, and then you use the identity. Does it matter which numbers you use? No, because I could have used 60 degrees and I could use 45 degrees and 60 degrees, and that still would have given me the same answer. Yes, this part right here would have, I would have had 45 and 60 instead, but once I simplified everything, it would have given me still the same answer. So I'm going to do the same thing for sine of 7 pi over 12. This time, you have to figure out what two radian measures are going to add together to give you a 7 pi over 12. Well, if you're like, oh, I'm really not good with fractions, then fine, convert it to a degree, and then figure out what 2 degrees you need to use. Because at the end of the day, everything's going to simplify down to be, a value from your unit circle. But you can use pi over 4 and pi over 3, and you can add them together. That gives you 7 pi over 6. Remember, common denominator, that's how you get 7 pi over 6. So then I can use that identity. Sine pi over 4, cosine pi over 3, plus cosine pi over 4, sine pi over 3. So again, two angles that will give me this measure here, and then I use that identity. The sine of pi over 4 is root 2 over 2. The cosine of pi over 3 is 1/2. The cosine of pi over 4 is root 2 over 2. The sine of pi over 3 is root 3 over 2. When I multiply these out, I get root 2 over 4 plus root 6 over 4, which is again another root 2 plus root 6 over 4. Will they always be this value? No. It just happens to be the same thing because, well, 30 and 45 degrees, they basically have the same set of ordered pairs. It's either going to be root 3 over 2, 1/2, or root 2 over 2. Now, depending on what other particular angles they might ask you to figure out the exact value of for sine and cosine, then those can be, those answers can vary. Okay? All right. So the last two problems are simplifying problems, and so this time we're actually going to go the other way. This is basically one of the identities stretched out. We have to write it in a more complex way. So this is basically cosine of a particular angle, cosine of another angle, minus the sine of the same angle from before, and then the sine of the same angle from before as well. Do we know an identity that says this cosine alpha, cosine beta, minus sine alpha, sine beta? We sure do. That is the cosine formula for alpha plus beta. Okay, that is the identity. So what do? Well, we plug in 70 for alpha, 20 for beta, and we get cosine of 90 degrees. Now, it is a simplifying problem. This can keep simplifying. What is the cosine of 90 degrees? That's the x value, 0. So that whole long thing of cosine 70, cosine 20, minus sine 70, sine 20 is equal to 0. That's what that simplifies down to be. And that's it. You just have to figure out, okay, which sum and difference identity is this, and then plug in the values for alpha and beta. So do the same thing. Sine alpha, cosine beta, minus sine beta, cosine alpha. Which formula is this? It's written a tad bit differently, but you can still figure it out. Hopefully you said that it was the one that says sine alpha minus beta. It's the same identity. And so for alpha, we're going to plug in pi over 12. For beta, we're going to plug in y. So this is going to be sine pi over 12 minus y. Now if you're like, well, can I go any further than that? No, we really can't, because we can't subtract pi over 12 and y from each other, and it's not like we're going to expand it, because then we'll just be going backwards. So this is your final answer. That is this particular problem simplified. Sometimes you'll get a number, sometimes you'll get an expression, but either way, it's the most simplest form for these particular expressions. So hopefully you watched the video, you took down your notes. If you want to give problems 11 through 16, or or sorry, 11 through 15 ago, that's fine. I will only be expecting you to have 1 through 10 done. But if you want to give it a try, just make sure you understand the concept. Please do. I mean, you're gonna have to get them done anyway, so why not, get them done now? I'll see you guys in class, next class.